Okay, so this is scatter plot of unstandardized predicted versus unstandardized residual. Okay, if your data looks like this, equal distribute, equally scattered above and below the zero line. Okay, so here is a zero line. Okay, here YR. Okay, YR. Y-axis for unstandardized residual and x-axis for unstandardized predicted values. So if you the scatter plot shows randomly scattered around equally above and below the zero lines, assume that the assumptions of linearity and equivariance are met. Okay, if the scatter plot shows like this, okay, like fan shape, okay, so it distribute, it's scattered like this, okay, so means that the variance are not equal and not linear, so the assumption is not met. Assumptions of equal variance and linearity are not met if the shapes looks like the fan shape or the concave shape. Okay, the concave, convex, okay, convex shape, okay, like this. Okay, sorry. Ish. Kenapa jadi macam ni ya? Okay. So kalau if the shape looks like convex, concave, so means that the variance are not equal and the linearity assumptions also is not met. So you cannot use linear regression. You cannot use simple linear regression, or you can do data transformations. You can cleaning your data. Okay, clean your data, remove the outliers to get the normality, to get the linear assumptions, linearity and homogeneity of variance assumptions to be met. For linearity and equivariance assumptions, you can check the scatter plot of unstandardized predicted value versus unstandardized residuals. Okay, and for the normality assumption, you can check the histogram of residuals. You create the histogram. Okay, and then the variable is unstandardized residual. So the histogram shows normal curve here, bell-shaped curve. So the normality assumption is met. Okay, normality is assumed. So all of the assumptions are met. Then you can proceed to interpret the results of linear regression. So what are the assumptions in linear regression? Can you remember? Can you remember the assumptions in linear regression?
Line.
Okay, line. Just remember line. So what is the L? What is I? What is N, E? Okay, line. Okay, L is the linearity. I independence, we not tested in SPSS. Okay, and N is normality, E equal variance. Okay, how to check the assumptions? Okay, how to check the assumptions? How to check the assumptions of linearity, normality, equal variance?
Kita plot dengan histogram.
Okay, scatter plot and histogram. Okay, so for linearity, we check the scatter plot of residuals versus predictor values for linearity and equivariance. And for normality, we check the histogram of the residuals. So this is we call the residuals diagnostic. Okay, then the last step, we interpret and make conclusion. Okay. So in linear regression, we need to interpret the R-square. Okay, first we interpret the R-square. So R-square reflects the effect size in the regression. In the regression analysis, so 0.727, okay, means that 72.7% or 73% of the variation in the body fat in the dependent variable is explained by the waist circumference. And we need to interpret the p-value of coefficients table, the p-value of for the B, for the regression coefficients. Okay, so here the p-value is significant, means that the waist circumference significantly and linearly associate with the fat thickness, or there is a significant linear relationship between waist circumference and the fat thickness. Okay, and then we need to interpret the value of unstandardized coefficients here. Okay, so what means the coefficients, regression coefficient? B 4.033. So it means that the individuals with 1 centimeter bigger waist circumference has 4.03 centimeter thicker fat. Okay, so the individuals with 1 centimeter bigger waist circumference has 4.03 centimeter thicker fat. So if the in the data the unit is in centimeter, okay, so you need to interpret as centimeter. Okay, and then here is the interpretation of confidence interval. Okay, we are 95% confident with 1 centimeter change in waist. The change in thickness of fat range from 3.5 to 4.57. Okay, so this is the confidence interval. Okay, and this one is the optional step. Okay, prediction. Okay, linear regression can be useful to predict the value of dependent variable for a given value of an independent variable. So we want to predict the y for a given value of x. We can use the regression equation based on the result. Okay, so here a study done to predict the fat from waist from a sample of adults. Okay, we can use the equation y equal to a plus bx. So the results, a constant here, negative 266.4. Okay, so here is the b. Okay, y is fat. Okay, a is the constant. The value of constant you can get from this. Okay, here is negative 266.446 and plus b. Okay, b is the regression coefficient here, 4.033. Okay, and this X ways. Okay. So criteria to determine the suitability of the regression equation for predicting values of the dependent variable. First, the result of the regression coefficient must be significant. Okay, so the p-value of coefficient table must be significant. That imply the statistically significant linear relationship between x and y. Okay, and then the R-square also must be large. A sufficiently large proportion of the variation in y can be accounted for by its linear relationship to x. So the R-square must be at least more than 0.5, okay, more than 50%. Okay, and then the regression equation should not be used to predict values of y outside the range of values for x observed in the sample. Okay, so based on our results, so we met all of the criteria. The p-value is significant. Okay, the R-square is good, 73%. Okay, and then the range of value, we can only predict the y with the waist circumference range 75 to 109 centimeter. So in our data, the minimum waist circumference is 75 and the maximum waist circumference is 109. So we can only predict the y from the x within this range. Okay, so for example here we want to predict for an adolescent with circumference 97 centimeter. So what is the y value if the x value 97 centimeter? Okay, so we just masukkan dalam equation the 97 centimeter for x for the waist circumference, and then you will get the predicted y. Okay, predicted fat is 124.51 centimeter. So the predicted fat in centimeter from equation is 124.51. Okay, so this is the observed fat from the data. If the sample have 97 centimeter waist circumference, the observed fat is 137, but the predicted fat based on the equation is 124.51. Okay, this is the table presentation for simple linear regression. Okay, so for the linear regression, simple linear regression, you need to present the B, the regression coefficient, 95% confidence interval, the T statistic, and the p-value. Okay, so all of these values of this result you can get from the coefficients table. Okay, so for the waist, this is the results. Okay, the other one is this one serum cholesterol and serum triglyceride we do not analyze. So this is just example of the table presentation. Okay, so correlation versus regression. Okay, difference. Causation. Okay, in linear regression, outcome is specified. Okay, the dependent variable or the outcome is specified. Characteristics, correlation merely, we just can assess the association. Okay, in linear regression, we clearly specify the dependent and independent variable. Okay, and the change in outcome if independent variable change, okay, we can determine in linear regression and also prediction in linear regression. Okay, any questions regarding simple linear regression?
Doktor, kalau nak tanya pasal correlation boleh tak?
Correlation, okay.
untuk non parametrik punya cara. So kena tabulate sama juga ke macam mana? Nak present.
Untuk Spearman correlation.
Betul.
Okay, untuk non-parametric, we use Spearman correlation. The table presentation sama je. Interpretation pun also same as Pearson correlation, but you need to mention the Spearman lah. So
Kalau
if
untuk t-test pun sama juga ada doktor.
untuk t-test lain.
Kena ada non bukan. Kalau contoh independent t-test, so kalau tak normal kita kena guna non parametric test. So untuk tabulate tu sama juga cara dengan t-test punya ke macam mana?
Cara interpret non-parametric test for independent t-test. Okay, so non-parametric test for independent, kita akan guna Mann-Whitney test. Okay, cara interpret dia. So you belum belajar lagi kan non-parametric test? Belum belajar lagi?
Belum. Belum. Oh, dia lain pula.
So yang itu for non-parametric test, different topics. So you will learn with Dr. Khairil in the next class. Okay.
Okay, doktor.
Okay, so for the simple linear regression, any questions? So you boleh faham tak dia punya konsep and the steps? Okay, so I'm aware that this topic is more complicated compared than the previous topics. Okay. Can we rest for 5 minutes before we proceed to do this exercise? Atau you nak buat sendiri? Or you want me to show, or you want to do by yourself, by your own? Boleh ke?
Buat sama-sama, doktor.
Sama-sama, okay. So we rest for 5 minutes.
Okay.